Hello children, today I am introducing a new topic called as polynomials. In your low classes or especially in the 9th standard, you must have learned that a polynomial is mostly represented as p of x, wherein x is the variable. The variable can keep on changing. It could be x, y or z, but basically always in most of the sums we take the variable as x. So p of x is nothing but in a way we are writing it as polynomial. But then what is so different about the linear polynomial? In a linear polynomial, the power of the variable will always be 1. That is, the highest power will be 1 and hence the degree will be 1. So when you talk about linear polynomial, you will see here that the degree here is always 1. And what is the general form of writing this polynomial? Because a polynomial is nothing but an expression. Its general form is always ax plus b, wherein, as I told you children, the power of the variable is going to be 1 in this case and hence its degree is going to be 1. Such type of any expressions you see will be called as a linear polynomial. Say example, if I want to give, I can also tell you as 2x plus 1. It is a linear polynomial. I can also say 3y plus 5. This is a linear polynomial. But children, if I say 1 upon x plus 2 is equal to 0, but children, if I say 1 upon x plus 2, then could you tell me, is it a linear polynomial? Is it a linear polynomial? Now you will say, ma'am, the power of x is 1. Power of x is not 1 because it is still in the denominator. If you bring it in the numerator, children, what does this become? It will become x to the power minus 1 plus 2 because you have reciprocated the base. And here the power has come minus, and so this itself is not a polynomial. Forget about linear polynomial because its degree or its power has to be positive and it may be 1, 2, 3, 4 whatever, but for a linear polynomial the power has to be 1. The power has to be 1 means the degree has to be 1. So in this case, first of all, it is not a polynomial. So in any case wherein your variable is coming in the denominator, right, those type of things are not polynomial at all. Now after understanding these examples and the linear polynomial, now let us see what is a quadratic polynomial. In a quadratic polynomial, now children, your degree in this case is going to be 2. And what is going to be general form? Its general form will be ax square plus bx plus c. Right? It means one more x is added over here, a variable. But see, what is the highest power? Here you will say, ma'am, here power of x is 1. Fine. But the highest power is 2. So in this case, the degree is 2. Like a expression of the form 2x square plus 3x plus 4. Yes, it is a quadratic polynomial because the highest power of x is 2. That is, the degree is 2. All such type of equation, even if I can say x square plus root 3x plus 10, yes, it is a quadratic polynomial. So all the polynomial with degree 2 are quadratic. All the polynomials with degree 1 will be linear polynomial. Coming to cubic polynomials, from the word itself you can understand, children, that in this case the degree is going to be 3. And when the degree is 3, let us see what type of general form do you get. Say like ax cube plus bx square plus cx plus d. Why? Because there is additional power added over here, which is 3. Now the highest power of the variable is 3 and hence the degree is 3. So all such type of expressions will be called as the cubic polynomials. If you have to see an example of this, we can say 3x cube plus 4x square plus 5x plus 1. Right? And keep in mind that your variable should be in the descending power, so you can quickly recognize what type of polynomial it is. So such polynomial with degree 1, that is the highest power of the variable should be 3, will be called as the cubic polynomials. Now after understanding linear, quadratic and cubic polynomials, let us now come to the zeros of the polynomials, a very important part of this chapter. Now first of all, you know children that a polynomial is represented by p of x. Now what in this case I am going to do is, I am going to choose any real number and I am naming it as k. You can name it anything. So if I choose a real number k and if I substitute the x in that polynomial by this k, then whatever value you get, that is called as the value of the polynomial p of x at x is equal to k and it is denoted by P of k. Now this part which I have explained is very important. So the moment you have any polynomial with you, say like this one, I am coming to that example. So if you have a polynomial with you and you have to choose randomly any real number. Now that randomly which one to choose comes with practice. So you have to choose any real number k, and this x in the polynomial, that is these values, should be substituted by that chosen real number. Now when I put that value of that real number in the polynomial, I am going to at the end of it going to get some value, and that is called as the value of that polynomial at x is equal to k. Why? Because we chose the k as a real number, and that is called as P of k. Now to understand it better and how is it related to zeros of polynomial, for that I have taken this example. Now imagine that this is the polynomial you are having. Now in that I am choosing a real number, say x is equal to -1. Now you will say, ma'am, you were saying k. Yes, for us our -1 is our k. K is -1, and I said that you have to find the value of the polynomial at x is equal to k. So that is why I wrote x is equal to -1. So for x is equal to -1, let me see what is the value of that polynomial I am going to get. So for wherever there is x, I am going to substitute -1. So P of -1 will be how much, children? -1 the whole square minus 3 into -1. If you want, you can put it in bracket, and -4. So there is no confusion. Don't forget to follow BODMAS. Now -1 whole square will be 1, minus, do the multiplication first, minus plus, and you will get +3 and -4. 1 plus 3 is 4, 4 minus 4 is 0. I had told you, the moment you substitute that x by that real number, you are going to get a value. In this case, I got the value as 0. Now hopefully you know how is it related or why it is called as a 0 of the polynomial. So for P of -1, I got the value as 0. So -1 is called as a 0 of the polynomial. Now the next question is, why then the word zeros? Because there can be more than such values for whom your answer can come 0. So let us choose another value, that is x is equal to 4. So I am choosing this time x is equal to 4. For that, let us see what value does this polynomial give us, which will imply P of 4, right, is equal to 4 square minus 3 into 4 and -4. After substituting the values, let us see, 4 square is 16, minus 12 and -4, 4 3s are 12, and you will get 16 minus 16, your answer is 0. Children, I had told you, there can be more than one real numbers for which the value of the polynomial can come 0. So here for -1 also we got the value of the polynomial 0, whereas for P of 4 also we got the value as 0. So you will understand that -1 and 4 are called as the zeros of the polynomial. So such real numbers which when substituted in place of x will give you the value 0 will be called as the zeros of the polynomial. So children, just now we studied about the zeros of the polynomial. Now let us understand the geometrical meaning of the zeros of a polynomial. Suppose there is a polynomial P of x given to you, and I told you, you have to choose any real number k. If you choose a real number k and you substitute that value of k in those variables in the polynomial, and if P of k, if at all it comes equal to 0, then that k is called as the zero of the polynomial. Now some polynomials may have only one zero, some may have more than one, some may have more than two. So how do you decide it? But now I am going to telling you it geometrically also. Now see children, there are 6 graphs which I have shown you over here, and by looking at the graph, how do you decide the zeros of a polynomial? Now keep in mind children, the zeros of the polynomial, whenever you have to look at the graph, you have to just see that graph, where does it intersect, or rather how many times does it intersect your x-axis. That decides the zeros of the polynomial just by looking at the graph. And also it tells you how many zeros is that polynomial going to have. So it also decides what type of polynomial it is. a linear polynomial or quadratic polynomial or cubic polynomial. Just by looking at the graph you can understand all that. Now as I told you, you have to check on the x-axis where is that graph intersecting and at how many places is it intersecting. So when I look at the graph, children, this is your x-axis, this is the y-axis, this is the graph, that the red line is marking you the graph. It's a straight line graph. But what do you see? That this graph or this line is not touching the x-axis at all. So how many zeros it will have, children? It will have no zeros. It means this equation, or rather this polynomial, has no zeros over there. Coming to the second graph. Coming to the second graph, if you see, it is touching the x-axis only at this one point. So how many zeros is this equation or this graph we are going to have? This graph is going to have 1 0 as its solution. But children, also come to know that whenever the polynomial expression is given to you, you will put the value of x and y in it and you will plot a graph. Here the plotted graphs are already given to you, but practically they have plotted the graph and then they have checked how many zeros do you get theoretically also and geometrically also, I mean algebraically also and geometrically also. So here there is only 1 0. It means, children, that there is only one real number k which will satisfy that polynomial. So that is only for that value, one value, your p of k or that p of 1 will come equal to 0. So from that you also can come to know that this must be a linear polynomial, right? Now coming to this, here you will see in this graph, children, that it is intersecting the axis at 1, 2, x-axis at 3 places. It means how many zeros does it have, children? It will have 3 zeros of the polynomial. Looks to be a cubic polynomial, because a cubic polynomial will have 3 answers or 3 zeros for the polynomial. So from the graph you do also understand what type of polynomial it is and how many zeros is it going to give you. Coming to the next graph, children, here you must have seen that it is intersecting the x-axis at 2 places. So obviously its answer will be, it will have 2 zeros. And where do you have 2 zeros, children, or 2 values? Especially for a quadratic polynomial. Now, so I told you here it will be a linear polynomial. Here it does not, it is not a polynomial. That is the meaning of it. I had told you initially also that whenever your variable is coming in the denominator, then that time it is not a polynomial. So when it is not a polynomial, then obviously it will have no zeros. So here it must not be a polynomial. Here it must be a linear polynomial. Here it has to be a cubic polynomial. Since it has 2 values, children, and this shape is also called as a parabola. So for a quadratic equation, basically you are going to get this type of shape. Also from the graph you come to know it is intersecting x-axis at 2 places. So it has 2 zeros and hence it's a quadratic polynomial. Coming to this, so it has 1, 2, 3, 4 places. So it is having 4 zeros in this case. And here if you check, you are again going to see, children, here is one place. Here it is just touching the x-axis. It has not intersected it fully, just touching, and here also. So how many zeros are you going to get over here? You are going to get 3 zeros. So obviously again like this it is going to be a cubic polynomial. So just by looking at the graph, geometrical meaning of the zeros of the polynomial can be understood. Children, these graphs are plotted according to the equation giving value of x and y. Equation is in front of them. They are putting the value of x and y, plotting a graph, and from the graph also you can find the number of zeros, also the zeros value. Also here I haven't showed you the values, but by looking at where it is intersecting also you can know the zeros directly. But it's a long process because you have to plot the graph. Let us now come to an important part called as the relationship between the zeros and the coefficients of a polynomial. Now for that I have explained you what are the zeros, but we will just now see what are the coefficients of a polynomial. But before that, let us see through an example this full concept of relationship between the zeros and the coefficients of a polynomial. Now when I am saying this is a polynomial given to me, children, first I am going to split the middle term. So when I split the middle term, I have 3 into minus 2 is minus 6. How do I split this, children? Because I want my sum to be 5. So if I do 6 ones are 6. 6 ones are is going to give me 6. But I want a plus sign. So can I do plus 6 and minus 1? Because plus 6 minus 1 will give me plus 5 and plus 6 into minus 1 will give me minus 6. So these are my two terms for splitting the middle term, 6 and minus 1. So how do I write? 3x square plus 6x minus x minus 2, right? So this is actually your polynomial p of x. Now, from these two terms I take 3x common, so what do I get? X plus 2, and minus I take 1 common, so I get x plus 2. Why? Because both were having minus sign, so I took minus common. So what do I get, children? X plus 2 and 3x minus 1. Now from this, what do we say? That value of x is minus 2 or value of x is 1 by 3. So these are the two values for this expression what you are getting, for the polynomial you are getting. These are the two factors. From this you got these two values, but then children, these are also called as the zeros of the polynomial. So what are the zeros of the polynomial in this case? Two values for which this expression or this polynomial is going to give you the answer 0. So that is why your zeros of the polynomial, zeros of the polynomial are minus 2 and 1 by 3. So what did we do? We took the polynomial, we split the middle term, and we got these two values which are called as the zeros of the polynomial. And now let us see how do you relate with the coefficients of a polynomial. Now when you have the polynomial in front of you, children, isn't it of the type ax square plus bx plus c, that is a quadratic polynomial? In that, you know value of a is how much, children? Value of a is 3. So I will put it over here. Value of a will be 3, value of b will be 5, and value of c is going to be minus 2, that is the constant. Now we have to see these are the coefficients of the polynomial and these are the zeros of the polynomial. What is the relation between them? For that, what we will do is, first we will do sum of the zeros. And then we will do the product of the zeros. Right. Now when I do the sum of the zeros, what are these zeros, children? Minus 2 and 1 by 3. So I will just plainly add them. So I do minus 2 plus 1 by 3. I am just adding them. What do? I take the LCM 3. 3 into minus 2 will give me minus 6 and plus 1, and my answer is going to be minus 5 upon 3. Is this understood, children? I found the zeros of the polynomial by splitting the middle term, and now I am doing sum of the zeros. Sum of the zeros I added and I got minus 5 by 3. Now let us see, I am trying to give a relationship between these zeros what you did and the coefficient. Now children, when you look over here, 5, isn't 5 a coefficient of x? And when you look at 3, isn't 3 a coefficient of x square? But you will say, ma'am, that 5 has a minus sign. No worries. How do we write? So we will write minus coefficient of x and whole divided by coefficient of x square. Hopefully this is understood. So what did I do? I found the zeros, I added them. When I added them, I am trying to relate them to the coefficients of the polynomial, and I saw it is minus 5 by 3, that is the minus of the coefficient of x and upon coefficient of x square. So this is what is going to give you your sum of the zeros. But children, can you tell me minus coefficient of x, what is the coefficient of x called as? B. So can I not write it as minus b upon what is the coefficient of x square? Isn't it called as a? So minus b upon a. So sum of the zeros will be given by the formula minus b upon a. So you are relating the zeros with the coefficients of the polynomial, right? Hopefully that is understood. So in short, after this explanation, I can directly write that the sum of the zeros is equal to minus b upon a. In the similar fashion, I am going to explain you the product of the zeros. When you say product of the zeros, that is minus 2 into 1 by 3. So I am doing minus 2 into 1 by 3, and what do I get, children? Minus 2 by 3. Now when I see minus 2 by 3, isn't minus 2 my constant for the polynomial? And what is 3? 3 is the coefficient of x square. So can I write it now? Here there is no question of minus because already your constant is having a minus sign, is equal to constant term upon what, children? Upon 3 is the coefficient of x square. Coefficient of x square. But children, what is that constant term called as c? So I will write it as c. And what is coefficient of x square? A. So c upon a. So now I understood that the sum of the zeros will be directly given by minus b upon a, whereas the product of the zeros will be directly given by c upon a, and that is the relationship between the zeros and the coefficients of the polynomial. Sum of the zeros as minus b upon a, and we had got product of zeros as c upon a. But instead of writing every time sum of the zeros, product of the zeros, there is a shorter way of understanding it, children. Alpha and beta, these are the symbols which are used for the zeros. So alpha, beta are zeros of the polynomial, So if you assume alpha, beta as the zeros of the polynomial, then can I not write, instead of sum of zeros, can I not write, children, alpha plus beta? I am adding the two zeros which I have named as alpha and beta, and for the product of the zeros, can I not write it as alpha beta? And this is an important relation between the zeros. Which are the zero, children? Alpha, beta, and coefficients of the polynomial are these. So just by directly writing these equations, you yourself can set up a relation between these two. But just don't forget that alpha, beta are the zeros of the polynomial, wherein a, b and c, you must know that they are the coefficient respectively of x square and x and a constant for a given polynomial. Hopefully children, this part about the zeros of the polynomial you have understood very well. Thank you so much.